quick refresher on what all these numbers mean. This guy, you know what he does? He does things upside down. This guy tells you it's a U-graph. You're going to see why. This guy tells you it's skinny. This guy tells you left and right, and he is going to be right too. And this guy tells you up and down, right? So the reason I'm doing that is because we're going to use this stuff now with trig, and you're not going to hate it. You're going to like it. You won't. So watch what he looks like. I know he's a U. I know I'm going to go over 2, up 4. I know he's upside down, and I know this dude is super, super skinny. And he's going to go like that. And I'm done. That's sketching. And you know what? You had a multiple choice test like we did. You all found that really easily. Only one thing changes on this next one. It's a lightning bolt. Instead of being a fat lightning bolt, it's a very skinny one. And instead of going like this, he flips upside down. He goes the other way. Can you try it? Because all that matters, Owen, is that you know the shape of this, then you just move it around. We're not even going to plug any points in. Shh, guys. So we're going to go over 2, up 1, 2, 3, 4. Here's what he would normally look like. He'd normally look kind of like a lightning bolt, but in this case, what he's going to do, he's going to flip the other way and be really, really skinny. So he's going to be super skinny and look like that. Super easy. Nice, nice. You did. And seriously, that's sketching. No, did you notice there was no T-chart? There's no plugging in points. That's literally going to get you what you need. If you need something more specific, you're going to use technology. You're going to use your Chromebook. No, I'm afraid of saying yes to teenage slang. It's like, oh, she just said something about sex, and I'm awkward. And you know what? I'm on a video now, so thank you for that. Okay, so here we go. Oh my God. I got you yellow paper. I got you yellow paper for a reason. Because, ready? Once we get the basic shape, all we're going to do is move this dude around. So today, we are going to make one T-chart. We're going to make one T-chart. And once we get the hang of it, we will never make another T-chart. Graphing trig is one of my, hey, you guys, I can't keep talking over you. So decide if you want to leave and just watch the video later, you can, but I need you to be quiet. Thanks. Graphing trig functions is one of my favorite things. One is because I get to make noises like this, like, woo, I just like doing that. And two, it's when you get the hang of it, it's super easy. And you know me, I like super easy stuff. So let me tell you what it's going to look like. We are going to be graphing something that looks kind of crazy like this. Y equals sine. Now, here's what's interesting. Some textbooks will call it sine X, and some textbooks call it sine theta. My software does both, and I end up doing both. So I need you not to freak out if I have a theta in there or if I have an X. It's the same thing. Doesn't really matter. Here's what's important to know. We're going to be plugging in angles here, and we're going to be getting out numbers here. And here's what I want you to think about. We're going to have the unit circle. And think about if the unit circle was Pac-Man, right? Here he is. He's Pac-Man. And imagine what I did is I cracked Pac-Man open, which would be mean. I cracked him open, and I put part of him up here, and I twisted it and put the other part here. That's what we're doing. I'm actually going to show you a really cool thing that shows exactly what we're doing. We're taking this and we're cracking it open and putting it on this. Because here's what's cool. we can keep doing this around and around, and we can keep going forever and ever and ever, right? I, I do, I do. Um, I like this stuff. And when you get the hang of it, it's super, super easy. But that's what we're doing. And so what we're going to see is we're going to take this, we're going to take all these points, we're going to put them on here. Now, the first thing I want you to do, okay, again, I'm taping. Um, I don't want you to freak out tonight. We're going to use a lot of stuff called pi. We can't use degrees. Here's why. Degrees aren't real numbers. Pi is just decimals. Am I going to use decimals? No, decimals are stupid. I'm going to use little pies, and it's going to be super easy. But I want you not to freak out and think, why is she using stupid pi? Because I'm too lazy to use decimals, right? And you're going to like it. So here we go. I need you to write this on your whiteboard desk because we're going to simplify it in a minute and put it on your notes. Are you ready? Okay, so here we go. Here is this crazy, crazy unit circle. Now, what we're going to do, one time only, is we're going to make a chart, and then we're going to graph it. But I don't like a bunch of these numbers. So let me show you what we're doing. We're taking this guy, and we're going to match him. So that's our angle. We're going to match him with sine. We're taking this guy, and we're matching him with sine. We're taking this guy, and we're matching him with sine. We're taking this guy, and we're matching him with sine. We're taking this guy, and we're matching him with sine all the way around the triangle. But here's what. These are dumbass numbers. Like, they are literally the stupidest numbers in the world. And I don't like them. I could, and maybe your teachers in the other classes, I could do it like this. So here's what it would look like. Don't write this, just watch. 0 goes with 0. Pi over 6 goes with 2 pi over 2. Oh, no, goes with 1/2. 4 pi goes with root 2 over 2. So I'm going to stop right here. Does everyone understand like where I'm getting these from? Yeah? So here's what. I don't like them. They're too ugly and scary, and they're going to make me cry. So let's take off the ones we don't like. Are you ready? This is a dumb number. We're not going to worry about him. This is a dumb number. This is a dumb number. Oh, I like those ones. I like ones. One's my friend. So we're going to keep him because I'm lame. You know what else I like? I like this guy and that guy because he's 0. 0 makes me happy. I like this guy and this guy because he's -1. And he makes me happy as well. And there's another guy over here. There's 2 pi, and he's back to 0. And you know what? I dig that guy. Nice and easy. Nice and easy. So we're going to pick those out. So I'd like you to write this on your paper. This is our one chart. Are you ready? Here we go. The easiest chart you've ever done. People who had Algebra 2 trig last year are going to be like, oh my God, this is so much easier than I thought it was. Okay, here we go. Nice and easy. Sign up. So the first thing is we're going to take this pair, pi over 2 and 1. We're going to put pi over 2 and 1. Is everybody cool with that? Now, I'm going to put a 1 here. And you're going to see why in a minute, right? I'm going to put a 1 there. Now, let's go around and do this dude right here. That would be pi and 0. But you know how this guy is a fraction? That's like 1 pi over 2. I'm going to make this guy a fraction too, because you know what? We're going to see in a minute. It makes a nice little pattern, right? See how that's 1 pi over 2 and then 2 pi over 2? Guess what this one's going to be? 3 pi over 2. Yeah, do you see the goofy pattern, right? So guess what we're going to do? We're going to keep on going. What's going to go right here? Any guesses? 2 pi, but how could I write that as that little pattern? 4 pi over 2. You guys are on fire. And look, it's at 0. Now, here's what I want to know. What about 5 pi over 2? Do you guys see a pattern here? I went to this guy. 5 pi over 2 is up there. It's 1. Throw it on there. Because guess what? We're going around the circle again. So that was 4 pi over 2, right? That will be adding one more, 5 pi over 2. And now, how about this one? 6 pi over 2, what's that going to be? Any guesses? 0. How about 7 pi over 2? What's that going to be? -1. And how about the very last one? 8 pi over 2. Okay, big finish. Are you ready? We're going to graph this baby. Oh, stop. You'll like it. I know. I have no life. Like you're just like just now we're thinking this. That's right. It's like, it is amazing that I'm married. Shocking. Are you? No, he was pretty normal. Yeah, I kept my nerdness on the down low. Okay, are you ready? So we're going to start with 0 right here. We're going to put down our stuff on the bottom, our X stuff. So watch why I did that fraction-y stuff. So we're going to start right here. 1 pi over 2. 2 pi over 2. 3 pi over 2. Have I lost anybody? We still going? 4 pi over 2. 5 pi over 2. 6 pi over 2. 7 pi over 2. 8 pi over 2. Now I'm stopping there. Could I do 9 pi over 2 if I wanted to? Sure. Could I go -1 pi over 2? I could. And you're going to see in a minute, you're going to be able to do it. Now, here's what's interesting. The highest this goes is 1. And the lowest it goes is -1. Do you guys agree with that? You're looking at your little chart. So let's put them on. You ready? Let's get a nice red pen. Let's start. 0, 0. Boom. 1 pi over 2, I'm at 1. 2 pi over 2, I'm at 0. 3 pi over 2, I'm at -1. 4 pi over 2, I'm at 0. 5 pi over 2, I'm at 1. It totally makes this little path 0. I love this stuff. Now, I want you to think about something. Look, I even know this guy. I didn't even do the math and I know him. And guess what? I know this guy over here without even doing any math. Here's what. You know those collapsible rulers that they're all sharp and you collapse them down? This is not a collapsible ruler. You're in the ocean and you're on your boat. Waves do not go like that. That would be horrifying to be on an ocean that had waves like this. This is wavy. It is wavy. So watch what it does. And if you want to make the noise like woo, it's fun. So do it. Here it goes. Woo. See, Jason's over there doing it because you can't not do it. You have just graph sign. And we will never use the chart again because now we know the shape of it. This is called a sinusoidal graph. Any graph that goes in waves is called a sinusoidal graph. And they're beautiful and they're cool and they go on forever and ever. The domain is infinite. This is an arrow. It's going to keep going up and down. This is an arrow. It's going to keep going up and down. But here's what's interesting. The range is just between 1 and -1. It's trapped in there. It's like a little heartbeat thing. Yes. We're going to do that in a minute. And it's super easy. It's super easy. Wait, it just shifts over a little bit. Wait. Okay. So here's what. Yes. Oh, good question. The domain, and we'll talk about this tomorrow, all real numbers, and the range, actually, I think it gets, no, it actually touches 1. Now, just like our class opener, we can mess with stuff on him. We're eventually going to put numbers here. We're going to put numbers here. And we're going to put numbers here. And you know what's going to be weird? They are going to do the exact same things they do on those other graphs. Skinny and fat, up and down, shifting left and right. It's so fun and easy. But we're going to start today. Okay, shut up. It's not fun. We're going to start with this guy. Now, here's what's cool. The problem that we started with looked like this. It started with this, and here he is. I'm going to graph him real quick. It started with, it went to 1 pi over 2 and 2 pi over 2. I'm just getting him up here real quick. I'm not going to do a ton of him because I'm just rushing here. And 5 pi over 2. Okay, here's what he looked like. Choo, 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 right? Okay. Here's what I did. I hit here at 1 and positive 1 and negative 1. Then, okay, tell you this is the new stuff. The stuff in front, in here, that was a 1. We didn't show it because we didn't need to. That number in the front has a special name. He is called the amplitude. And in real life, if you go to Mavericks and you want to watch in February the Mavericks surf thing, they will talk about wave amplitude. It's how high your wave is. And in this case, when it was 1, how high did my wave get to? It got to 1. I am now changing this to 3. It just goes up to 3 and everything else stays the same. Yep. You know, if you were super lazy, you didn't even have to do this. You could have just done this. That's what's cool about trig graphing. All we're going to be doing is changing these stupid numbers. So you don't even have to change your graph. Yeah. Ooh, we're going to do that. We're going to do that. So amplitude tells how high your wave is. It doesn't change anything else. If you're going to Hawaii, you want an amplitude to learn to surf of about 3 to 4. Anything smaller than that, you'll fall off your board. Anything bigger than that, it's scary when it's over your head. Okay, now, what if we have this? Y equals -2 sine theta. Do you remember in our very beginning problems, positive ones went up? What did negative ones do? They flipped upside down. So let's watch what this dude is going to do. So here we go. We start with our little pi's, right? 0, 1 pi over 2. You're going to get so used to doing these that it's going to be super fast. 3 pi over 2, 4 pi over 2, 5 pi. Oh, my pi looks awful. Over 2. It's right now, it's always the same set of numbers. Eventually, we're going to make them, but we'll just change the number and keep the shape the same. Okay, now 2 is the biggest it gets, and -2 is the smallest it gets, but in this case, it heads down first, right? Because now he's flipped upside down. So instead of going up and down, he's going to go down and up. So easy.
So if it starts with a negative, it has a negative in the number.
You head to the negative. You head to the negative. What do you think? Yeah, I love it. I love it. I love these. Now we got time for one last thing, and then we're going to wrap it up. That is sine. What the hell happens with cosine? And I'm here to tell you, not a lot. Not a lot. Oh wait. Yeah. Domain on this one. So the domain is always going to be real numbers. You got it. The range on this one, -2 to +2. Sure. The amplitude and the domain or the range are the same. Great. Great question. Okay. Last part, best part. I'm going to make a chart. You don't have to make the chart if you don't want to, but here comes cosine. Y equals cosine theta. Really? So Tim, why don't you guys just go ahead and go on out? So one, you're not supposed to have your phone. Uh, this is awkward because I am taping and I can't really stop taping. And two, it's brand new stuff. And three, you're interrupting me. So go, just the three of you, just leave. I go to the library. If you don't want to learn it, be on your own. But you literally can't make my life harder. Okay, so here we go. We only care about the easy stuff. This time it's this guy and the cosine. 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 We're going to keep on rolling, right? We're going to do 2 pi and 1, right? So we're going to keep on rolling. So here we go. Are we ready to make our chart? So easy. So we're going to start with 0 and 1. Then we're going to go to 1 pi over 2, and we're at 0. And we're going to go to 2 pi over 2, and we're at -1. I like those numbers. Then we're at 3 pi over 2, and we're at 0. We're all the way around our circle, so we're at 4 pi over 2, and we're at 1 again. But we want to keep on rolling, right? Because we're on a roll. 5 pi over 2. What do we get when we're at 5 pi over 2? We're at 0, right? 6 pi over 2, and we're at -1. 7 pi over 2, and we're at 0. And finally, 8 pi over 2, and we're back at 1. Let's graph it. And you're going to be like, really? That's so disappointing. We were really hoping it would be more interesting, but it's not. So here we go. 0, 1 pi over 2, 2 pi over 2. I'm going to make my pen thinner because that looks awful. 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Okay, lambs, you graph it. Graph it. Put your dots on. There's only, when you do it, you're going to be like, really? It looks almost the same. And there's only one tiny difference. And we'll talk about what that is in a second. One, -1. You know what the difference is? It starts at 1. Sine starts at 0, and cosine starts at 1. That is literally the only difference. It works exactly the same. But you do strangely have to remember that, because every year I teach this, I have to think to myself, which one starts at 0? Which one starts at 0? Oh, sine does, right? Because otherwise, they look exactly the same. Do they work the same way? Sure. Could I change the amplitude and make my waves bigger? Absolutely. Could I flip them over to start instead of at +1 at -1? Absolutely. They work the exact same way. Sine starts at 1. Write that down. Sine starts at 0. And I just said the wrong, I know, sine starts at 0, and cosine starts at 1. See, I get them flipped. Yes, exactly the same. Highest I go is 1 and -1. That's amplitude, and it goes on forever. So here's what you're going to try to do tonight. In a second, you're going to go run and get your phone. I have a few of these to try on blank paper. Here's what we don't want to do. We don't want to try to use graph paper because look at these dumbass numbers. Don't try to do them on tiny graphs. They're dumb. Just do them on blank paper because all we're going to do is just, guess what? If I change this to cosine 4, guess what I would do? Change that to 4. Done, right? So blank paper is our friend. Grab your phone, take a quick pick. This is your homework to try. You got a few. We're doing that tomorrow. You're trying a few of these. Yes. No. Yes, I certainly can. I see that on there. I can end it.